Right now, somewhere in the world, there's a country burying tens of thousands of its own people after a magnitude 7.5 earthquake flattened 80% of an entire coastal city in under 2 minutes. The confirmed death toll has passed 4,100. More than 50,000 people are still missing. Refrigerated trucks meant to hold the dead are completely full. Bodies are being laid outside in the June heat because there is nowhere left to put them. A forensic pathologist working inside a makeshift mortuary at the port of La Guaira estimated her team was processing 400 bodies per day, many of them decomposed beyond recognition. 27 days before that happened, on the other side of the planet, Japan took a magnitude 7.4 earthquake. The shaking was felt by tens of millions of people across 6 prefectures. A 3-meter tsunami warning was issued. 175,957 people were ordered to evacuate. Bullet trains stopped automatically. Coastal towns emptied, and when it was over, 10 people had minor injuries. Nobody died. Not a single building collapsed. A 7.5 in Venezuela. Thousands dead, tens of thousands missing. Nearly 59,000 buildings damaged or destroyed. A 7.4 in Japan. 0 fatalities, 233 structures with minor damage, life back to normal by morning. Almost the same magnitude, almost the same raw power released into the earth. 2 results so far apart, they should not exist on the same planet. And the reason for that gap is not luck, not geography, and not the earthquake itself. It is something far more uncomfortable. It is a choice. A series of choices made by governments, engineers, and citizens decades before the ground started moving. And what those choices were is the single most critical thing anyone living near a fault line needs to understand right now. Today we are breaking down exactly what happened in both countries, minute by minute. What the buildings were made of, what the governments built and what they ignored, what systems existed to warn people, and what happened where no warning systems existed at all. The engineering, the data, the confirmed numbers, and the specific decisions made years ago that determined who lived and who died on the day the Earth moved. No guessing, no dramatizing, just the facts and the full picture. Drop a comment right now. Have you ever personally felt an earthquake, a small tremor, or something that shook your whole building? Tell me where you were and what it felt like. Thousands of you are watching from earthquake-prone countries, and I always want to hear those stories. If you want real investigative breakdowns like this every single week, subscribe right now and turn on notifications. You do not want to miss what we cover next. A thumbs up tells the algorithm to push this to people who genuinely need to see it. Let us go for 5,000 likes on this one. Now, let us get into it. On June 24th, 2026, at 6:04 in the evening local time, the San Sebastian fault system beneath northern Venezuela broke. A magnitude 7.2 earthquake ripped through the crust near the town of Yumare in the state of Yaracuy, roughly 160 kilometers west of the capital Caracas. Before people could even process that first shock, before they could get under a table or reach a doorway, a second rupture tore loose 39 seconds later on an adjacent segment of the same fault. Magnitude 7.5. The combined shaking lasted 90 to 120 seconds. Italy's National Institute of Geophysics and Volcanology analyzed satellite ground deformation data and concluded the 2 events were effectively one complex rupture measuring magnitude 7.6, tearing along a 210-kilometer stretch of fault from the city of Moron to northeast of Caracas. The maximum fault displacement reached 3.6 meters at a point offshore north of Cadia Lamar, at a depth of just 11 kilometers. Shallow. That single word explains a significant portion of what came next. When a fault ruptures at 10 to 11 kilometers depth, almost all of the released energy reaches the surface at full intensity. There is no thick cushion of rock to absorb the seismic waves before they reach the buildings, the roads, and the people above. The ground acceleration in the worst affected zones hit modified Mercalli intensity 9, classified as violent. Objects were thrown. Structures that could not flex were torn apart. And the structures above that fault were the worst possible type to face that kind of force. In La Guaira, the coastal state directly north of Caracas, and directly above the rupture zone, 80% of buildings collapsed. That figure came from Venezuela's acting president in a national address. It was later confirmed by satellite analysis. NASA's Sentinel satellites estimated that nearly 59,000 buildings across the country were damaged or destroyed, a figure wildly different from the government's initial report of roughly 800 structures. The pattern of destruction told a very specific engineering story. CNN reviewed and verified dozens of videos showing residential towers that had pancaked, their floors stacking on top of each other in the classic failure mode of soft-story buildings, structures with weak columns and open-ground floors that offer almost no lateral resistance to horizontal shaking. Rescuers digging through the wreckage of collapsed apartments found walls made of styrofoam sandwiched between thin concrete panels, not reinforced concrete with steel rebar designed to flex under seismic stress, styrofoam. a material with zero structural value in an earthquake. The LA Times reported that before the June earthquakes, engineers had already published warnings that tall buildings on soft soils in Venezuela had a greater than 80% chance of collapse under violent shaking. The government's Mission Vivienda housing program, launched under Hugo Chavez after the 1999 Vargas mudslides, had built housing rapidly and at scale. But DW in the New York Times reported that some of these state-built structures used substandard materials and lacked adequate seismic reinforcement. They were built to provide shelter, not to survive an earthquake. And the San Sebastian fault did not care about the difference. Venezuela had updated its seismic building codes after a deadly earthquake struck Caracas in 1967, killing 240 people and collapsing several high-rise buildings. The updated codes were aligned with international standards, including provisions from the American Concrete Institute. The problem was not the codes on paper. The problem was that enforcement was never prioritized. According to civil engineer Juan Carlos Vielma, quoted in Wikipedia's sourced article on the disaster, the codes existed but were not applied consistently, particularly in the rapid construction boom of the 2000s and beyond. The result was a city full of buildings that had seismic codes written for them but not built into them. A children's hospital in Catia Lamar collapsed, killing 16 children and injuring 35. A 22-story building in the Altamira district of Caracas collapsed entirely. 14 of 20 floors in the Petunia residences in Los Palos Grandes pancaked into rubble. The Edwards Hotel in La Guaira collapsed completely, killing family members of professional baseball players who were staying there. More than 100 Venezuelan citizens who had just arrived in La Guaira on a deportation flight from the United States went missing after the hotel they were housed in collapsed. At least 32 of them were confirmed dead. The USGS pager system, which issues red-level alerts only once or twice per year globally, estimated a 44% probability the final death toll would fall between 10,000 and 100,000 people. A 30% probability it would exceed 100,000. The United Nations sent 10,000 body bags. The United Nations Office for Disaster Risk Reduction estimated total direct damage at $37 billion, roughly 6% of Venezuela's GDP, erased in under 2 minutes. Now cross the Pacific to Japan. On April 20th, 2026, at 4:53 in the afternoon local time, a magnitude 7.4 earthquake struck off the Senriku coast of northeastern Japan along the Japan Trench. The Japan Meteorological Agency initially measured it at magnitude 7.7 before settling on its final assessment. The earthquake ruptured a 70 by 65 kilometer section of the plate boundary with a maximum slip of 4.7 meters near the hypocenter at a depth of 35 kilometers. Peak ground acceleration reached 0.44 G at a seismic station in Morioka, Iwate Prefecture. Within seconds of the rupture initiating, Japan's earthquake early warning system detected the fast-moving P waves and pushed alerts to every mobile phone in the affected zone. The system, operational since 2007 and considered the most sophisticated in the world, provides between 5 and 60 seconds of warning depending on distance from the epicenter. Those seconds triggered automatic responses across the country. Shinkansen bullet trains began emergency braking. Factory equipment powered down. Elevators stopped at the nearest floor and opened their doors. Tens of millions of people received a notification on their phones telling them to brace for shaking before the destructive S-waves arrived. A tsunami warning for waves up to 3 meters was issued for parts of Iwate, Aomori, and Hokkaido. Evacuation orders went out to 175,957 people across 40 municipalities and 5 prefectures. Coastal residents moved to higher ground in the same practiced, orderly response that the country has drilled into its population for decades. An 80-centimeter tsunami reached Kuji Port in Iwate. Smaller waves hit Miyako, Urikawa, and Sendai. The warning was downgraded within hours and fully lifted by 11:50 that night. Final toll. 10 injuries, 2 serious. 233 buildings damaged, none catastrophically. Roughly 200 households lost power temporarily. 0 deaths, 0 collapsed structures. Life resumed the next morning. The reason is not one thing. It is an entire civilization-scale system built over a century of learning from its own disasters. Japan introduced the world's first national seismic building code in 1924, 1 year after the Great Kanto earthquake killed more than 100,000 people and burned much of Tokyo. That code has been strengthened repeatedly, with the most transformative overhaul coming on June 1st, 1981. The new anti-seismic design standard, still the foundation of Japanese construction law, requires that buildings withstand severe earthquake shaking without collapse. The standard does not promise the building will be undamaged. It promises the building will not kill the people inside it. After the 1995 Kobe earthquake killed over 6,000 people, Japan launched a national campaign to retrofit every building constructed before 1981. Schools received priority. By 2011, roughly 90% of public school buildings had been seismically reinforced. When the magnitude 9.1 Tohoku earthquake struck that same year, not one retrofitted school collapsed. Japan has constructed more than 2,600 seismically isolated buildings, according to research presented at the Applied Technology Council. Base isolation technology places rubber and steel bearings between a building's foundation and its superstructure. During an earthquake, the ground moves violently. The building above the isolators moves slowly, absorbing the energy rather than fighting it. Hospitals, government emergency centers, data facilities, and residential towers across the country sit on these systems. During the April 2026 earthquake, buildings swayed gently rather than shattering. People braced, objects rattled, and then it was over. But the engineering is only half the story. The other half is something you cannot bolt onto a building. It is cultural. Japanese children begin earthquake drills in elementary school. They practice dropping under desks, covering their heads, holding on. They learn where their local evacuation centers are. They carry emergency supply kits. These drills continue through middle school, high school, and into adult life. Workplaces run them. Cities run them. The entire country participates in annual National Disaster Preparedness Days. Japan experiences roughly 1,500 felt earthquakes per year. Earthquake readiness is not a government program. It is a national reflex. When the April 2026 tsunami warning was issued, coastal communities in Iwate and Hokkaido did not wait to see water. They moved. This is the same coastline where the 2011 tsunami killed nearly 20,000 people. 15 years later, on the same fault system, a magnitude 7.4 killed nobody. The geology did not change. The people changed. Now place those two realities next to each other and look at the gap directly. Venezuela updated its building codes after 1967. Japan updated its codes after 1924, after 1981, after 1995, and after 2011. Venezuela wrote the codes but did not enforce them. Japan wrote the codes, enforced them, then retroactively upgraded every building that predated them. Venezuela had no earthquake early warning system. Millions of people in Caracas and La Guaira had 0 seconds of notice before the ground started shaking. Japan's system detected the April earthquake and pushed alerts to mobile phones within seconds, giving people time to take cover before the violent shaking arrived. Venezuela had no systematic public earthquake drills. Japan trains its children from age 6. Venezuela was in the grip of a severe economic crisis when the earthquake struck. Nearly 8 million people were already in need of humanitarian assistance before June 24th. Hospitals were understaffed and undersupplied. Infrastructure maintenance had been deferred for years. Japan spends billions annually on seismic resilience, early warning systems, retrofit programs, and disaster preparedness education. The investment is enormous. The return on that investment, measured in human lives, is absolute. The earthquake did not decide who lived and who died. The buildings decided. The codes decided. The enforcement decided. The drills decided. The warning systems decided. The choices made by human beings over years and decades, long before the fault slipped, determined everything. And that is the single most important fact about earthquake risk anywhere on Earth. The magnitude is nature. It is physics. It is the planet doing what it has done for 4.5 billion years. No human being can stop it, or slow it down, or predict the exact day it will happen. But the death toll is not nature. The death toll is a human decision. It is the accumulated result of every choice a society makes about how it builds, how it trains, how it enforces, and how seriously it takes the ground it is standing on. Japan took a 7.4 and walked away. Venezuela took a 7.5 and may never fully recover. The difference between those two outcomes is not buried in the earth. It is built above it. If you found this useful, share it with someone in an earthquake-prone region. That one share could genuinely change how they think about the ground beneath their feet. Subscribe for real science breakdowns every week. And tell me in the comments, what does your country do to prepare for earthquakes? Because the answer to that question might be the most important thing you ever learn about where you live.